Okay, Ethan, what we got? So this proof, oh, 2 proofs and a word problem. That's not too bad. I can get that done pretty quickly. Sarah Moses is in here taking tests, so bless her heart, she has to sit and listen to me. Okay. So let's get our givens. Angle 1 is congruent to angle 2. Okay, so 1. Ooh, I'm going to go ahead and go with that because I'm trying to prove RJMO. So I'm trying to prove that the big parallelogram is a parallelogram. And that first given got me one part of it. So if angle 1 and 2 are congruent, then there's my transversal. Those are alternate interior angles. So now I know that RO is parallel to JM. Oh, I forgot the right given right there. Because congruent alternate interior angles imply that you got a set of parallel lines, okay? What's our next one? Number 3. P is the midpoint, so mark them off as I do them, is the midpoint of RO. Okay. So P is the midpoint of RO. That means this is congruent to this. Oops, stay put. Ugh. Keeps moving around for some reason. So RP is congruent to PO because of the definition of a midpoint. Okay, got that one. We know that PS is congruent to KS because it's given. All right, so PS. Oh, so right there is congruent to KS right here. Now that makes S the midpoint. Should I do that one or not? I'm going to hold off. I'm going to put a little star. It might be helpful to say S is the midpoint, but I don't know if it is or not yet. K is the midpoint of JM, so that's going to make this congruent to this. Okay. K is the midpoint of JM. So that's my last given. Oh, I wonder if this is going to lead me to a midpoint theorem. If it is, I might have to come back and adjust this. So that's the definition of a midpoint. All right, what should we do? Oh, I see it. So those are parallel. That's 2's and 3's. Oh, I've got that vertical angle right there. All right, let's start with a vertical angle. This is definitely congruent to this, okay? I think I'm going to come back and change my mind about this step and this step. I think I'm going to end up doing midpoint theorem. That seems more reasonable. All right, let's get this one though. So angle PSO is congruent to angle KSJ because vertical angles are congruent. All right. If I can show that angle 3 and 4 are congruent, then those 2 triangles that I just highlighted, they'll be congruent because of angle side angle. And then I can have those corresponding parts be congruent, which will tell me that these are the same length. Ooh, okay, yeah, I'm pretty sure I'm going to come back and get rid of that one. But let's keep going. What's going to be the best way of saying that? wait, no. I don't have to. I was sitting here thinking that I could say that these form a linear pair and do all that kind of stuff, but I don't have to because I've already proven that these lines are parallel back up here in step 2. So if those lines are parallel, then angle 3 and angle 4 are alternate interior angles off that same blue transversal. So angle 3 is congruent to angle 4 because parallel lines imply congruent alternate interior angles. And now I can say, okay, so here's what we got. Angle, angle, and then the side is the one that's SK. Where's that? That's this side. So I do need that one. And I do need this one. So I don't need to go midpoint theorem there. Do I? Oh no, PS and KS, that was given to me. So hang on, I still may adjust this. Okay, so this step and this step, that's where I did the midpoints and went to the congruent segments. Ooh, we'll see if I'm going to need it. I may not need those steps in there. I may, though. Ugh, there's a lot to think about. So I have enough, though, right now to make those triangles congruent. So triangle JSK is congruent to, okay, so J is the one that's not labeled. That's going to be the O. What did I do next? S, that's going to be S in that one, and then P because of angle, side angle. Okay, and then I also know that JK then is congruent, so JK is congruent to OP because corresponding parts of congruent triangles are congruent. Now, all right, this is going to look weird. I'm going to come back, because I called it OP here, because I have to. I'm going to come back up here in step 4 and change that to OP so that it is easier for the reader to understand what's happening. Okay? So then, number 12, this means using this step here and this step. Since they're both congruent to OP, they're congruent to each other. So I know that JK is congruent to RP with a transitive property. Again, remember, no substitution on a congruency symbol. So that's got to be a transitive property. You can only substitute numbers. All right, so let's see how that's going to change how my JK. So now instead of 3 tick marks, we'll just use 1. Okay. Oh. Well, I'm almost done. Because that makes, okay, so 13. I knew that P was the midpoint up here, right? And K is the midpoint there. I know these two pieces are congruent. All right, let's see if I do, what if I just start out with this? Because I'm going to be adding stuff together. I know that JK equals RP. Because that's the definition of congruent segments. Okay. So if I want to have a JK and an RP in there, then instead of the way I wrote it here, I did go back. No, I used this one. I need to keep it. JK and KM. I think I could go back and let's get rid of, I'm going to change step 7 because I want to have JKs in there, and I never technically need that congruency step, do I? Did I ever use that one? JK. Oh, no, I did. Never mind. I'm going to leave it. So JK was congruent to KM. No, because I never used the KM part. Change your mind again, Ethan. What if we just do, if K is the midpoint, then we know that JK is half of JM. And then if P was the midpoint, then we know that, let's see, so 14. OP is half, oh, I gotta change this midpoint theorem. It's half of RO by the midpoint theorem. And let's see, half of RO. JK, why did we do, well, I didn't even need that. JK. I guess you're getting to see how a proof really does happen. Because this is how you do a proof. Like, it takes a little while. I don't think I needed JK and RP. I don't think I needed that one at all, did I? The JK and the OP, this is the one I actually needed. All right, none of this is false. So let's just keep going, and maybe we'll take some stuff out later. What if I go to here then? That JK equals OP, because that's true. Boy, this one's going to be a mess. I hope that you're doing it better than I am. So JK equals OP is the definition, definition of congruent segments. Okay. And then, so OP is half of RO. JK is half of JM. That's not what I want. Man, I've made this way tougher than it needs to be. What should we do next? There's JM and JK. Did I ever say JM? Anything about JM? Got that, RP. I gotta have something to plug in here to tie it all together. And I've got so many things written down, I don't know what I want to use. Like, I know, here's what I'm looking for. I'm going to make it a parallelogram, because I know that's true. And I was trying to get around adding those two up and setting them equal to each other. But, because I want to get to saying RO equals JM. Okay, so that's what I'm trying to get to here. So I need stuff with ROs and JMs. Let me highlight that. Let's see if I can find them all. ROs. Okay, here's something with an RO in it. I don't have anything with a JM in it. Oh, I do right there. Okay, so there's JM. Do I have anything with an RO and a JM? I don't. Okay. Oh, wait. Okay, I think I got some. So what if we take the two I just highlighted and I multiply both sides by 2? Hey, Miss Beverly. I'm making a video, so I'm not talking to myself, I promise. No, not today. So this is the multiplication property of equality. So then we knew that JK equals OP. Oh wait, it would have been easier. What I should probably do is just worry about getting done instead of trying to find the easy way. Because obviously, I have not found the easy way. So JM or something like that. Oh, what if I just go back here then? Okay, so 17. I'm already up to 17. JM. No, that's just going to end up with JK equals JK. That's not helpful. OP. What if I did that there? And maybe I didn't even need this step. Let's see. OP is half of JM. I'm just going to write this. So OP is half of JM is twice JK. So OP, half of 2 is 1 is JK, which makes OP congruent to JK. And that's what I wanted, wasn't it? No. I wanted RO and JM. Ah! OP. All right, I'm just calling it. I'm looking. Because I know I could get there if I did a segment addition and then it ended up setting them equal to each other. I'm just trying to figure out, what am I missing? Because I did it in 15 steps, and I'm already at like 20. So let's see what I got. Okay, so I did that. I said they're parallel. I said that those two angles were the same. I did it angle 3 and 4. I said that, but I said it in step 3 the first time I did it. I said this PS is congruent. Oops, I lost that segment bar. To KS. I said that. And then I went straight to the things being congruent. Oh, because I needed these two to get the angles. So I made the congruent triangles. Then I said that JK was congruent to OP. I did that. Oh, JK is congruent to OP. Oh, that's when I pulled in the midpoint. So P was the midpoint. I waited a little down there. And I did the K was the midpoint. I waited a little down at step 8. And then I did that JK was half of JM. I did that. OP was half of RO. I did that. And then I didn't do these steps. Okay, so I totally left that out. Let's see, and let's get rid of this. Ooh, I'm glad I didn't try to do this before. Whatever that was, duty this morning. So let's just call that number 12. I'm going to move it back up. With the midpoint theorem. Okay. Now I'm not going to look. I got to figure this out. So far, so I'm trying to get RO and JM the same. Okay, how am I going to do that? Okay, I've got, let's put these back in. I like the highlighter part there because it's got the JM and the RO in it. So what if, which I guess didn't need to erase this. What if I call this the next step? I think that's one of the ones I just erased. So I could have left it. Okay. JK is OP. So JK is half of JM. Oh, here it is. OP is half of RO. Well, duh. I just need to get all the other junk out of the way so I can see it. So that was a substitution. I could double both sides. So that's the multiplication property. That makes JM congruent to RO, because that's the definition of congruent segments. And then, let's see if I've got it. Here's where I said RO and JM were parallel. Here's where I said they're congruent. Now I can say that, what is it called? RJMO is a parallelogram. Because if a quadrilateral, I didn't like quadrilateral. Let's try it again. Has one pair of opposite sides that are both, well, that is both, because pair would be the subject, so that means it is. That is both congruent and parallel. Then the quadrilateral is a parallelogram. Okay. Oh, I still got to grade your test. Man, it's not going to happen if it takes me 20 minutes to figure out a proof. All right. So hopefully this one goes better. All right, let's see what's happening here. So triangle AED and triangle BEC are isosceles with bases AD and BC. All right, so AED with base AD. So that means that's congruent to this. And then this one, base BC, that means this is congruent to this. Okay. So I could say that AE is congruent to DE, and also that BE is congruent to CE, because that's just the definition of an isosceles triangle. So it's a triangle with at least two congruent sides. All right, well, so I took care of the first given. Let's go ahead and mark up the second given. So AD is congruent to BC. So AD, 1, 2, 3, congruent to BC. Oh, well, those two triangles are congruent. What am I trying to prove? This thing's a parallelogram. Okay. Well, the two triangles aren't necessarily congruent. Those aren't the same length legs. We don't know they're the same length legs, but what we do know is that that angle is congruent to this one, and that this angle is congruent to this one. So let's put that in there. So angle DAE is congruent to angle, what, ADE? We also know the angle, I want to call it EBC. That seems like a good thing to call it. It's congruent to angle ECB, because when we have a triangle with congruent sides like that, we have congruent angles across from them. Okay, so we got this given. All right, let's figure out where we're going to go with this. Well, I do know these angles are congruent. Let's see if I can work with that. So, angles AED and angle AED, let's say BEC. Those are congruent because vertical angles are congruent. Okay. How are we going to get... Oh, wait. I think I did the wrong angles being congruent. Should I look at those two little ones instead? I think I might should. No, maybe not. I think I'll probably use that. Ooh. What if we worked our way... All right, this could get interesting. Let's turn these into measures. All three of these last congruency statements. So that's just the definition of congruent angles. All right, so in this triangle up here, let's say the blue one, because we can't say they're congruent yet. I don't know enough to know that. However, what I do know is, so in the blue one, I know that the measure of angle, I wish I could just put numbers in them. That would make things so much easier. What do I call this one? DAE plus the measure of angle, what do I call this one? AED plus the measure of angle ADE. I know that's 180 degrees because the sum of the interior, of the measures, go away, this pen is not cooperating. The measures of the interior angles of a triangle is 180 degrees. All right, now I also know that same thing for the green triangle. And let's call it, we'll call it the same things we call it here. So what do I call that one? BEC. Yep. So the measure of angle BEC added to the measure of angle, did I call it ECB? I did. Plus the measure of angle, what do I call that one? I'm guessing EBC, did I? EBC. Yeah, EBC right there. That's 180 degrees. So those two things have to equal each other. Oh, this is long. So the measure of angle DAE added to the measure of angle AED added to the measure of angle ADE equals the measure of angle BEC added to the measure of angle ECB added to the measure of angle EBC, because that's just a substitution. Okay, now which of those is the same? EBC, okay, that one, so I'm looking right here, and ECB. No, that's not the one I want. I need the same thing on both sides. So that's going to be those vertical angles. Where's the vertical angles? Right here. So let's find those. AED, right here it is. and BE. Oh, right there it is. So I can subtract that off each side, which leaves me with the measure of angle DAE added to the measure of angle ADE equals the measure of angle ECB added to the measure of angle EBC, because that's the subtraction property. I just subtracted two equal things, or one equal thing off the same side. All right, so DAE and ADE, oh, they're the same thing. So I'm going to take that and plug it in here. And then I'm going to take, okay, ECB, where's that one? ECB, oh, right here. I want to plug that right here. So angle ECB, that's the same as the measure of angle EBC. Holy cow. Which is a substitution. I need to make sure I go back and print this off. I think I already printed it yesterday, but I need to print it just on the fronts, because you write bigger than I do. You're gonna go onto the back, I think. So then two of these make two of these, because that's just a substitution. I'm putting something at equal value in. Then I can divide both sides by 2. Please tell me I did the right angles. I haven't even looked the correct angles. So that's a division property. Are those the ones I needed to be equal? A, D, E. Okay, so that's this angle here. E, B, that's that angle there. Oh, here we go. We're almost there, finally. Someone come up here to step 13. That's going to make angle ADE congruent to angle EBC because of the definition of congruent segments. Now, if those two angles are congruent, which they are, that makes these lines parallel because they're alternate interiors. So AD is parallel to BC because congruent alternate interior angles imply that you have a set of parallel lines to form them. And now I've got, let's do a different color, let's do green. I've said those two sides are parallel. Right here I said they're congruent. So now I know that ABCD is a parallelogram because if a quadrilateral has one pair of opposite sides that's both parallel and congruent, then that quadrilateral is a parallelogram. Whew. And I didn't look on that one. Thank goodness. That one was a little bit more, well, it's not any more straightforward, but I didn't get lost in the weeds on that one, so that's good. All right, and then the last one, which is going to feel like a breath of fresh air after those two proofs. We've got a rectangle is 4 times as long as it is wide. So this is x, this is 4x. Perimeter's 200, so that's going to be 2 of the x's plus 2 of the 4x's. Let's just divide both sides by 2. So 5x is 100. X has got to be 20. What do they want? Oh, are we done already? Find the length and width. So it was 4 times as long. So this was the length. This this was the width. So if this is 20, this is 80. So the length is 20 centimeters and the width is 80 centimeters. That seemed too simple. Make sure I got this right. No, I did. Maybe it's just those proofs tore me up, and now that seems real easy. All right. So you're going to have some work from section 11 too, and I can't remember if there's anything else too. These notes took long enough, so that might keep you busy all day. I'll get to that next. Where are we at? 10:24. It didn't quite take all planning period. It took longer than I thought it would, so oh well. Good luck.